Hi guys, okay, we're going to look at trig in 3D, which is essentially trigonometry in 3 dimensions, a bit like Pythagoras, but this time we're going to find angles and use SOHCAHTOA. So this is an example, guys, straight into it again. It's find the angle the line EA makes with the plane ABCD. So this is a common question, guys. It's a common difficult question. It's always towards the end of the paper, but it's the angle between the line and a plane. Now the plane is like this, it's like a surface, so it's like a face of the shape. So ABCD, this is a plane, and when he says the line EA makes with the plane, we need to find an angle. Now the first kind of tricky bit is to figure out, well, what angle is he talking about? Okay, so let us draw a triangle. So key points again. First is draw a right angle triangle in 3D. Then draw this triangle in 2D, work out the required sides, use SOHCAHTOA. Okay, so the line EA, let's start with that, EA. Now, when we want to go right, what's the line that it makes with the plane? A common error, this would be a mistake, would be to go right. It's that angle there. That is wrong. Wrong. That is not the angle that it makes with the plane. The angle that makes with the plane, a bit like with Pythagoras, you have to come straight down from this top guy here, straight down to the plane, and then this is the right angle triangle that we're going to make. Like if you did that, what I did earlier, it wouldn't even have been a right angle, but this is a right angle because this is flat. Imagine this is like flat on a table, and this is vertical. So this, even though it doesn't look like it in 3 dimensions, is a right angled triangle. This is a right angle right there. Okay, that's good enough. Okay, that is the right angle triangle. So let's draw this right angle triangle in 2 dimensions. Okay, we've this, and we've this, and you can see obviously there is the right angle. Okay, now we have, well, this is A, this is E, and this is the middle point here. If we want to call it M, I guess we could, M for middle, but you don't have to call it anything. What we're actually trying to find is this angle here. Let's call it theta for fun. Okay, we're trying to find angle theta. We have 18. We have this side here. It's this AE. What we don't have is, well, any other side. But we can use, and this is kind of like a follow-on from the previous lesson, we can use Pythagoras down here to create some kind of another triangle to help us find this. Now I guess, guys, you could actually put a line here and say that these two are equal, but I think it's more straightforward if I just join this here, and this is a new green, again, right angle triangle here, right angle triangle there, and I'll find this big hypotenuse. Let's just do it over here, and then with the hypotenuse I will, let's actually square, guys, so I'll try and draw these the same length, and I'll half it. Whatever this hypotenuse is, we'll half it. So let's call it x. This is x, this is 10, this is 10, this is the right angle, this is A, D, C, like this. X squared is equal to 10 squared plus 10 squared. X squared is 200. X is equal to the square root of 200. I'll leave it like that for now. X is the square root of 200. So x is the square root of 200. I think, actually, guys, I'll just do square root of 200 on my calculator is 10 root 2, because I'm going to half it to get the side AM. So the AC is 10 root 2, which means AM is 5 root 2, because this is half of this, because we're only going halfway. Okay, now we have an adjacent and we have a hypotenuse, so I can use cos. Cosine of theta is equal to adjacent 5 root 2 over hypotenuse 18. Theta is equal to the inverse cos of that, inverse cos, shift cos, put in a fraction, 5 root 2 over 18, close bracket, and I get 66.87. Let's go 2 decimal places. 66.87 degrees. Does that answer make sense? Yeah, why not? It doesn't look too bad. Okay, so that's kind of, well, I wouldn't even say that's a basic question. That's a fairly difficult question. But I am going to do a past paper question now that's even harder. So we have, this is my mark scheme hiding here. We are going to do this question here. Okay, so we have a solid prism. This is a trapezium. It's given a few things, 37, 28. Importantly, guys, the midpoint of BC is vertically above the midpoint of AD, so just so the middle here is right above each other. Perpendicular distance is 20. Okay, fine. Calculate the size of the angle between AF and the plane ADEH. Okay, so again, guys, we're going to draw a triangle. So I'm going to go, let's draw a red triangle here, guys. AF. We are trying to find the angle between AF and the plane. So there's AF, and the plane is this ADEH, the same thing, just like my previous example. And then the angle is where? Well, again, you have to come back to vertically below the top. So I go straight down from the top, and I stop when I get to the plane, and then I go across to the point where the angle is. So it's this angle that we are trying to get. Again, I'll call this theta. Okay, now I have this length here. It's 20. Thankfully, I have one length. It's 20 because of this. The height is the same across because it's the prism. So I have that. What I don't have is any other length. I don't have this one, and I don't think I even have a way to find it. Well, certainly not before I find this length. I can find this length here, but I need to do this because it's not actually, hang on, he's not actually at the corner there. So I'm going to draw a line from here to here, and then from here to here. This is a right angle triangle again, guys. Right angle triangle. That's 37. No, sorry, that's not 37. Be careful. That is not 37 at all. Now, what is that? Well, because, look, see this line here, this 28. I'm going to have to do it over here to show you guys. This is 28. And then this is 37. So this is like the front face of the trapezium. This is 28. And this is 37. Now he says the midpoint is directly above this one, so they are in, it is in the middle, which means this and this are the same. They're the same length, and it's symmetrical. So if I was to draw a line, well, let's use orange. If I was to draw a line down here and down here, this distance is the same. Now, because this is 28 and this is 37, this is 9. Oh, sorry, this plus this. Well, that's not straight, guys, but you get my point. This plus this is 9. So this is actually 4.5, and this is 4.5. Because with 37 plus 4.5 plus 4.5 gives me the 28. So that's this little bit here. So that length there of this triangle is not 37, it's actually 37 minus 4.5. So I'm actually going to draw this orange triangle like this. Okay, that's not great, guys, right? Let's try that again. Okay, better. That's a right angle there. This is 24. This is fine. This is 24. So this is A. And now it's not even, this is not even E. So why don't we call this, I don't know, let's call this P. And let's call this Q. So that's P and Q. That's 24. This is 37 minus 4.5, which is 32.5. So 37 minus 4.5 is 32.5. Now I have a right angle triangle. I can find this value here. I haven't used x yet. Let's just use x. X squared equals 24 squared plus 32.5 squared. X is the square root of that. Let's do it all in one go. The square root of 24 squared plus 32.5 squared. This is 40.40111. I'm going to write all of that, guys, down. 40.40111. 40.40111, because I'm not at the end of the question, so I'm not going to round too much yet. And then, now that I have x, when I draw my red triangle, let's draw my red triangle here. This is now A, P, F, this is 20, this is a right angle, and this is X, the AP. This is 40.40111. This is the angle we're looking for. I have the opposite and the adjacent, so I'm going to say tan of theta is equal to 20 over 40.40111. Theta is the inverse tan of that. Shift tan 20 over 40.40111, close bracket, 26.337. 26.337. He says 1 decimal place, so let's go 26.3 degrees, which I guess makes sense. Okay, so obviously, guys, not an easy question, lots of work to do, but yeah, that's how you do it.